Hello friends, welcome to Middle Geekers Academy. Today we are discussing second exercise of pair of linear equations in two variables. This is graphical method of pair of linear equations in two variables. Using graph, we can find the solutions of the linear equations that we will study in this exercise. Also, we will study by using ratios of the coefficients how to conclude whether the given pair of linear equations has solution or not. Let's come to the first question. Form the pair of linear equations in the following problems and find their solutions graphically. In exercise 3.1, we had already discussed in detail how to find graphs of linear equations. So here I will directly explain you how to find solutions using graph. First bit, it is given that 10 students of class 10 took part in mathematics quiz. If the number of girls is 4 more than the number of boys, find the number of boys and girls who took part in the quiz. So let us consider the number of boys and girls who took part in the quiz as X and Y respectively. Total there are 10 students in the class. So sum of the number of boys and number of girls is 10. So here we get the first equation, x plus y equals to 10. Read the second condition. If the number of girls is 4 more than the number of boys. 4 more means we have to add 4 in the number of boys. So number of girls means y equals to number of boys plus 4. So the second equation is now y equals to x plus 4. From equation 1, what is the value of y? It is 10 minus x. Second equation, it is already y equals to x plus 4. Let us find points. Consider the first equation, y equals to 10 minus x. If we substitute x equals to 0 in the first equation, it gives 10 minus 0, that is 10. So the first point is a 0, 10. Now put x equals to 8. So 10 minus 8 gives 2. So we get the second point as 8, 2. From the second equation, y equals to x plus 4. If we put x equals to 0, we get corresponding y value as 4. So the first point is 0, 4. And if we substitute x equals to 1, so 1 plus 4 gives 5. So the second point is q 1, 5. Let us plot these 4 points on a graph paper. So the first point is a 0, 10. Where it should lie? Correct. It should lie on y-axis. So here it is a 0, 10. The second is 8, 2. So it is 8 and 2. So we get here B point. Join A and B. This is the first equation. From second, the first point is 0, 4. So it lies on y-axis, P point. Q is 1, 5. So here it is 1 and 5. So we get the second point Q here. Join PQ. This is the second line. As you can see, these two lines intersect at 3, 7. So let this point be C, 3, 7. From graph, we can observe that the lines intersect at a point 3, 7. So first value is of x and second value is of y. So here we can conclude the answer The number of boys who took part in the quiz are 3 boys and number of girls are 7. Now come to second bit. In this it is given that 5 pencils and 7 pen together cost rupees 50, whereas 7 pencils and 5 pens together cost rupees 46. Find the cost of 1 pencil and 1 pen. Let the cost of 1 pencil be rupees x and cost of 1 pen be rupees y. From the given conditions, we have 5x plus 7y equals to 50. Since cost of 1 pencil is rupees x, cost of 5 pencils will be rupees 5x. Similarly, cost of 1 pen is rupees y, therefore cost of 7 pens will be 7y. Together the cost is given, it is rupees 50. In this way we get the first equation, 5x plus 7y equals to 50. From the second condition, 7 pencils and 5 pens together cost rupees 46. We have 7x plus 5y equals to 46. Convert the first equation. From first equation, we have 7y equals to 50 minus 5x. And then divide both sides by 7, we get the value of y as 50 minus 5x upon 7. Similarly, from second equation, we get y value as 46 minus 7x upon 5. Let us find points on these lines. From the first line, put x equals to 3. So if we substitute here x equals to 3, then it will be 50 minus 15 means 35 by 7, that is 5. So we get the first point a3, 5. On substituting x equals to 10, it becomes 50. So 50 minus 50 is 0. So corresponding y value is 0. So the second point is 10, 0. Similarly, from the second line, here put x equals to 8. So it gives corresponding y value as minus 2. And on substituting x equals to minus 2, we get corresponding y value as 12. So the 2 points are 8 minus 2 and minus 2, 12. Let us plot these 4 points on graph paper. First is a 3, 5. So from x-axis 3 and from y-axis 5. So here it is the point a 3, 5. B is 10, 0. 10, 0, it lies on x-axis. So here we get the point B. Join A and B. Similarly, the P point, it is 8, minus 2. It lies in fourth quadrant. So here it is P point. The next point is minus 2, 12. It lies in second quadrant, minus 2, 12. So here we get the second point Q. Join P and Q. So this is graph of second equation. As we can see, they intersect at 3, 5. From graph we can see that two lines intersect at 3, 5. As the first value is of x and the second value is of y, we can say that the cost of one pencil is rupees 3 and cost of one pen is rupees 5. Now let's start interesting concept of this chapter, that is consistency of linear equations. Consider two equations, a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0. Consistency of these two equations means to check whether these two equations have solutions or not. If these two equations have common solution, then we say that equations are consistent. If they don't have solutions, then we say that equations are inconsistent. Just by comparing the ratios of the coefficients, we can conclude whether the equations have solutions or not. First case, if a1 upon a2 is not equals to b1 upon b2, then equations have common solutions, means the equations are consistent. Algebraically, we can interpret that equations have unique solution, means there will be only one value of x and one value of y. Graphically, we can say that these two lines intersect each other. Second case, if a1 upon a2 is equals to b1 upon b2 equals to c1 upon c2, then also equations are consistent, means they have solution. But these solutions are infinitely in numbers, means infinitely many solutions exist. If we draw their graphs, the graphs are coincident lines, means overlapping lines. They are not distinct lines. Third case, if a1 upon a2 is equals to b1 upon b2, but not equals to c1 upon c2. In such case, equations are inconsistent, means they don't have solution. If we draw their graphs, they are parallel lines. So let's solve examples based on consistency of linear equations. Question number 2, exercise 3.2. On comparing the ratios a1 upon a2, b1 upon b2 and c1 upon c2, find out whether the lines representing the following pairs of linear equations are intersecting lines, parallel lines, or coincident lines. First bit. In this, a1 is 5, b1 is -4, c1 is 8, whereas a2 is 7, b2 is 6, and c2 is -9. a1 upon a2 is 5 upon 7, b1 upon b2 is -4 upon 6, means -2 by 3. Since a1 upon a2 is not equals to b1 upon b2, we can conclude that given lines intersect each other. Similarly, second bit, here a1 is 9, b1 is 3, c1 is 12, whereas a2 is 18, b2 is 6, and c2 is 24. a1 upon a2 is 9 by 18, means 1 by 2. b1 upon b2 is 3 by 6, means again 1 by 2. c1 upon c2 is 12 by 24, means again 1 by 2. So since all the three ratios are equal, means a1 upon a2 is equals to b1 upon b2 is equals to c1 upon c2, given lines are coincident. Let's solve third bit. In this, a1 is 6, b1 is -3, c1 is 10, and a2 is 2, b2 is -1, C2 is 9. A1 upon A2 is 6 by 2 means 3. B1 upon B2 is minus 3 upon minus 1 means again 3. C1 upon C2 is 10 by 9. That is, A1 upon A2 is same as B1 upon B2, but not equals to C1 upon C2. So we can conclude that lines are parallel. Question number 3. On comparing the ratios A1 upon A2, B1 upon B2 and C1 upon C2, find out whether the lines representing the following pairs of linear equations are consistent or inconsistent. First bit, 3x plus 2y equals to 5. 2x minus 3y equals to 7. So here A is 3, B1 is 2 and C1 is minus 5. A2 is 2, B2 is minus 3 and C2 is minus 7. A1 upon A2 is 3 by 2, whereas B1 upon B2 is minus 2 by 3. Since A1 upon A2 is not equals to B1 upon B2, given equations are consistent and have unique solutions. Similarly, second bit, here A1 is 2, B1 is minus 3 and C1 is minus 8. A2 is 4, B2 is minus 6 and C2 is 9. Let us find the ratios. A1 upon A2 is 2 by 4 means 1 by 2. B1 upon B2 is minus 3 upon minus 6 means again 1 by 2. And C1 upon C2 is minus 8 by 9. As A1 upon A2 is same as B1 upon B2 but not equals to C1 upon C2, given equations are inconsistent. Means they don't have common solution. Third bit, here A1 is 3 by 2, B1 is 5 by 3, C1 is minus 7, A2 is 9, B2 is minus 10 and C2 is 14. Let us find the ratios. A1 upon A2, this is 3 by 2 upon 9, 3 cancels with 9, so it is 1 by 6. B1 upon B2, it is 5 by 3 upon minus 10, that is minus 1 by 6. That is, A1 upon A2 is not equals to B1 upon B2. Therefore, equations are consistent and have unique solution. Fourth bit, here A1 is 5, B1 is minus 3 and C1 is minus 11. A2 is minus 10, B2 is 6 and C2 is 22. A1 upon A2 is minus 5 by 10 means it gives minus 1 by 2. B1 upon B2 is also minus 1 by 2, and C1 upon C2 is also minus 1 by 2. Since all the three ratios are equal, A1 upon A2 is same as B1 upon B2 is same as C1 upon C2, we can conclude that given equations are consistent and have infinitely many solutions. Last bit of this question. Here A is 4 by 3, B1 is 2, C1 is 8, minus 8. A2 is 2, B2 is 3, and C2 is 12. So A1 upon A2 is 4 by 3 upon 2. 2 cancels with 4, 2 by 3. B1 upon B2 is 2 by 3. C1 upon C2 is minus 8 by 12, means minus 2 by 3. That is A1 upon A2 is same as B1 upon B2, but not equals to C1 upon C2. Therefore, given equations are inconsistent. Question number 4 is same as 3. So you can solve this yourself. Let's switch to question number 5. It is given that half the perimeter of a rectangular garden whose length is 4 more than its width is 36 meter, means half the perimeter is 36 meter. Find the dimensions of the garden. Let us consider the length and width of the garden to be x meter and y meter respectively. From the given conditions, we have x equals to y plus 4. It is given in the question that the length is 4 meter more than its width, means length x equals to width plus 4. Also, it is given that half the perimeter of the garden is 36 meter. Perimeter of rectangle is 2 into length plus breadth equals to 36. Cancelling 2, so we get x plus y equals to 36. Means y is 36 minus x. And from the first equation, we have y equals to x minus 4. Let us find points on these two lines. From equation 1, y is x minus 4. So if we substitute x equals to 4, 4 minus 4 gives 0. So the first point is a4 comma 0. Now put x equals to 8. So 8 minus 4 is 4. We get the second point b 8 comma 4. From the second equation, y is 36 minus x. Put x equals to 20. The corresponding y value is 16. 36 minus 20. Now put x equals to 16. We get corresponding y value as 20. So here the 2 points are p 20 comma 16 and q 16 comma 20. So here is the graph of two lines. The first point a4 comma 0 on x-axis. The second point is b 8 comma 4 joining a and b. So we get the graph of first line. Similarly, p point 20 comma 16 and q point 16 comma 20 joining p and q, we get graph of second line. From graph, we can observe that these two lines intersect at point P 20, 16. So from graph, the two lines intersect at P 20, 16, means x is 20 and y is 16. Means the length of the garden is 20 meter and width of the garden is 16 meter. Question number 6. Given the linear equation 2x plus 13y minus 8 equals to 0, write another linear equations in two variables such that the geometrical representation of the pair so formed is intersecting, second is parallel, and third coincident. Given equation is 2x plus 13y minus 8 equals to 0. For intersecting lines, change the coefficients of x and y. Another equation of line is, you can take 5x plus 7y. Constant can be changed. So let this be 11 equals to 0. And you can check the ratio a1 upon a2, ratio of the coefficients. So it is 2 by 5. b1 upon b2 is 13 upon 7. Means a1 upon a2 is not equals to b1 upon b2. So here the required equation of line is 5x plus 7y plus 11 equals to 0. Second, for parallel lines, we know condition for lines to be parallel. a1 upon a2 equals to b1 upon b2, but not equals to c1 upon c2. So here the coefficients of x and y are to be taken as it is, or in the multiples of 2 and 13. So if we take coefficients of x and y as 4x plus 26y, take some other constant, say minus 7 equals to 0. Then you can check a1 upon a2 means 2 upon 4, which is 1 by 2. b1 upon b2 is 13 by 26, means again 1 by 2. And c1 upon c2 is minus 8 by minus 7, means 8 by 7. So here a1 upon a2 is same as b1 upon b2, but not equals to c1 upon c2. So this satisfies the condition of parallel lines. So the another equation of line is 4x plus 26y minus 7 equals to 0. Third bit, coincident lines. Condition for coincident lines is all the three ratios must be equal. a1 upon a2 equals to b1 upon b2 equals to c1 upon c2. As the given equation of line is 2x plus 3y minus 8 equals to 0, just multiply by any non-zero number. Another equation of line is, if we multiply by 5, so it gives 10x plus 15y minus 40 equals to 0. So the condition for lines to be coincident is satisfied. Question number 7. Last example of this exercise. Draw the graph of the equations x minus y plus 1 equals to 0 and 3x plus 2y minus 12 equals to 0. Determine the coordinates of the vertices of the triangle formed by these lines and x-axis and shade the triangular region. So here the given equations are x minus y plus 1 equals to 0. That is y equals to x plus 1. Let this be equation number 1. The second is 3x plus 2y minus 12 equals to 0. So 2y is 12 minus 3x. That is y is 12 minus 3x upon 2. Equation number 2. Let us find the points on these lines. X and y is x plus 1. In the third, x comma y. If we substitute x equals to say 0, corresponding y value is 1. So we get the point a0 comma 1. Now substitute x equals to minus 1, corresponding y value is 0. So the second point is minus 1 comma 0. Now the points on the second line, x, here y is 12 minus 3x upon 2 and x comma y. So if we put x equals to say 4, 12 minus 12 gives 0. So the first point is 4 comma 0. If we substitute x equals to 0, then we get 12 minus 0, that is 12 by 2 means 6. So the second point is 0 comma 6. Let us plot these 4 points on graph paper. So the first point is a0 comma 1. It lies on y-axis. So this is a point. Second is minus 1 comma 0. Minus 1 comma 0 is a point on negative x-axis. So this point is B. Join A and B. Second is 4 comma 0. 4 comma 0, the point lies on x-axis. So this point is P. The second is 0 comma 6. It lies on y-axis. So join PQ. As we can see, these two lines intersect at 2 comma 3. Lines intersect at 2 comma 3. So let this point be 2 comma 3. So it forms a triangle. It forms a triangle CBP. So this is the required triangle. So this completes exercise 3.2. Thank you.